Okay, having a wee look through the level 2 exercise. Question 1, find the range of values for which it is increasing. So there's your fx, it's increasing when the derivative is bigger than 0. So f dash x instead of dy by dx. So it doesn't matter if you put dy by dx in there. So differentiate that, put it bigger than 0. So it's quadratic inequality. Find your critical values by putting it equal to 0. Draw out your wee graph. A third and minus 1. You want, that should be at 0. You want above 0. So your graph is above the x-axis on this bit. So before x is minus 1 and it's above 0 after x is a third. Question 2. So you've got this curve and it wants the turning points and then sketching it. So your fx, to find a turning point, is f dash x, differentiate it. Now, I was reading the wrong question. Question 2. Find the range of value for which it is decreasing. So it is decreasing when f dash x is less than 0, so it's the same thing. Find your critical values, draw out your graph. You want under 0, so that's under the x-axis. So your graph is under the x-axis in this section here, between 1 and 3. Number 3 is one of these gradient function graphs, so there's a wee bit more to this. So let's look at this is the original graph here. In this section, it's positive. The gradient is positive. So the gradient graph is going to be above the axis. It then turns, so it is at 0. So your gradient graph is above the axis, but it must cross the axis here. This is negative, so it's below the axis, but it turns here at 0. So the graph must go through these 2 points, and it has to be beneath the axis, so that's where this curved shape comes in. There, it crosses the axis again, because that's a gradient equals 0 up there. So between these 2 points, or between my 2 fingers in both graphs, this is increasing. So it's above the axis, and that's how you do it above the axis to link up there. This bit is decreasing, so it's under the axis. And then you had to superimpose those together. So that will probably take quite a wee bit of work to get around that one. Number 4, this is the turning point one. So do dy by dx, put it equal to 0, solve it, get your x values. Once you've got your x values, put it in to get your y's. That's your 2 points. Now, the question specifically asked you to consider signs. It didn't let you use the second derivatives. That's a bit of a pain. But anyway, we have got x is minus a third. So, and x is a half. So what I did, you save the work a wee bit. Pick a number before minus a third, which I picked minus 1. Pick a number after minus a third, and I picked 0. Work out the gradient. The gradient is when you sub it in. So subbing minus 1 into dy by dx, the gradient is negative. Remember, at minus a third is 0, because that's the turning point. And put the gradient into, put 0 into the gradient, and you'll find it's a positive gradient. So it's that shape. So that's going to be a minimum curve at this one. Now, the next turning point was x equals a half. Before x equals a half is 0. So I just used that point again. Before 0 is a positive gradient, so it goes up. X a half is a turning point, so it's a flat gradient. And then the point I chose for after x half, I chose x equals 1, subbed it in, and it's negative. So you can see there it's a maximum turning point. Number 2 says sketch the curve. So what I'm doing here is I'm finding where it crosses the axes. So put x equals 0 to find where it crosses the y-axis. And then put y equals 0 to find where it crosses the x-axis. If you look there, you can factorise out an x. And then you've got a quadratic equation. Just use the formula. And that gives you where they cross the axes. And always put your minimum and maximum points in, given your full coordinates. Number 5. You have got the curve has got a minimum point. So first of all, you're told it goes through minus 4, minus 11. So before I did anything else, that's a point on the curve. So I subbed that in. Y is minus 11 and x is 4. That got me an equation. You were told it had a turning point x equals 4. So a turning point is when dy by dx equals 0. So I worked out dy by dx, put it equals 0, and you know that the x value is 4. So I subbed it in. And I got an equation which got me to work out p. I could then put it back into equation 1 to work out q. So then you rewrite your y in terms of your p and q. And then the question says find the coordinates of the maximum point. So it's maximum when dy by dx equals 0. So differentiate this, put it equal to 0 and solve it. There's your two coordinates. X equals 4 is the one you already have, so it's interested in this one. X equals 0. Remember to sub it in to get your y coordinate. And then check it's a maximum. Now I didn't go through the whole sign thing here, I just went through the second derivative. Differentiate again, put in your values for x and p. It's less than 0, so it's a maximum. And the last question. This curve goes through 1, 1. So first thing I did was I subbed in 1, 1. Then you're told it's got a turning point at -1 and at 3. So a turning point is when dy by dx equals 0. So put that equals 0, sub in x3 minus 1. Here's an equation. Sub in 3, that's into your dy by dx equals 0 equation. And you get another equation. Solve those two simultaneously to get a and b. And then put a and b back into your original equation to get c.